Good afternoon, dear students. Now I want to discuss equivalent weight. Equivalent weight. This is very important concept. Equivalent weight we can calculate for elements, acids, bases, salts, and for redox reactions also. First, elements. For elements, equivalent weight or gram equivalent weight is equal to gram atomic weight by valency. This is also known as n factor. Example, hydrogen. Its gram equivalent weight or equivalent weight is equal to hydrogen atomic weight 1 and valency also 1. Because hydrogen maximum it can form one covalent bond, so that's why 1, valency 1, that is n factor. So gram equivalent weight 1. Sodium. Gram equivalent weight is equal to sodium atomic weight 23 by sodium valency 1. First A group element it is lithium, sodium, potassium, rubidium, cesium, francium. So their valency 1. So 23 by 1, 23. Magnesium. Gram equivalent weight equal to magnesium atomic weight 24 by magnesium valency 2. It can form maximum 2 covalent bonds, second A group element. So 2. Answer 12. Chlorine. Gram equivalent weight equal to chlorine atomic weight 35.5 by chlorine it can form one bond. So 35.5 by 135.5. Aluminium. Its gram equivalent weight equal to aluminium atomic weight 27 by aluminium its valency 3. So 9. Oxygen. Gram equivalent weight equal to oxygen atomic weight 16, oxygen valency 2. So value 8. Like we can calculate for elements. Elements gram equivalent weight equal to atomic weight by valency or n factor. Now coming to acids. How can we calculate for acids? Gram equivalent weight equal to gram molecular weight of acid by basicity of acid. Or number of replaceable hydrogens. Simply it is known as n factor. Understood? How can we calculate? Gram equivalent weight equal to gram molecular weight of acid by basicity of acid or number of replaceable hydrogens or n factor. Monobasic acid or monobasic acids. Monobasic acids means one replaceable hydrogen is there. One replaceable hydrogen is present. So that's why n factor is 1. N factor 1. What is the n factor? N factor is 1. Understood? Example, hydrogen chloride, hydrogen bromide, hydrogen iodide, HNO3, H3PO2. Its name paspinic acid. What is this? Paspinic acid, etc. Paspinic acid, etc. Understood? HCl, HBr, HI, HNO3, H3PO2, etc. Here, hydrogen chloride, one hydrogen is there. Hydrogen bromide, one hydrogen is there. Hydrogen iodide, one hydrogen is there. HNO3, one hydrogen. But coming to H3PO2, three hydrogens are there. But when you are coming to HCl, HBr, HI, HNO3, one hydrogen is there. No doubt at all. They can provide one hydrogen. But when you are coming to H3PO2, there are three hydrogens, but it can give only one hydrogen. H3PO2, its name paspinic acid. There are three hydrogens present, but only it can provide one hydrogen. It can donate one hydrogen. That's why its N factor is 1. Why it is giving only one hydrogen? H3PO2. H3PO2. P double bond O, OH, H, H. Here, oxygen electronegativity 3.5, hydrogen 2.1. Here, electronegativity difference, delta En, electronegativity difference 1.4. Phosphorus electronegativity 2.1, hydrogen 2.1. 2.1. Here difference, electronegativity difference 0. Electronegativity difference 0. 2.1 minus 2.1, 0. Simply, these are non-polar covalent bonds. Non-polar covalent bonds. Okay, these are non-polar covalent bonds. But coming to here, electronegativity difference is in between 0.7 to 1.7. Approximately 0.7 to 1.7. That bond, that difference, any bond having that difference. So in between 0.7 to 1.7, then that bond is called polar covalent bond. Polar covalent bond. So it is breakable bond, okay? It is breakable bond. But pH bonds are non-breakable bonds. Non-breakable bonds. Non-breakable bonds. Very, very important concept. So that's why pH bonds are non-breakable bonds. OH bond is breakable bond, ionizable bond, polar covalent bond. So that's why it can provide this hydrogen. That's why its N factor is 1. Its N factor is 1. Understood everyone? Its N factor is 1. So gram equivalent weight of H3PO2, gram equivalent weight of H3PO2 is equal to its molecular weight by 1. Its molecular weight by 1. Its molecular weight by N factor is 1. Understood? Now coming to dibasic acids. Dibasic acids. Okay, dibasic acids. Understood? Dibasic acids. Two replaceable hydrogens present. Two replaceable hydrogens present. So N factor 2. N factor 2. What is the N factor? N factor is 2. So two replaceable hydrogens present. So N factor is 2. Understood? Example sulfuric acid. Two replaceable hydrogens, N factor 2. H2CO3 carbonic acid, 2 replaceable hydrogens, N factor 2. H3PO3, it is phosphonic acid. What is this? Phosphonic acid, etc. Phosphonic acid, etc. Here two hydrogens present, here two hydrogens present, but H3PO3 three hydrogens present, but it can give only two hydrogens. Remember, phosphonic acid H3PO2 replaceable hydrogen 1, phosphonic acid replaceable hydrogens 2. Now H3PO3, its structure P double bond O, OH, OH, H. Already I told you, I explained you based on electronegativity difference. These OH bonds are polar bonds, breakable bonds. So that's why the two hydrogens are replaceable hydrogens. But this is non-ionizable bond, non-ionizable bond, breakable bond, non-ionizable bond, because electronegativity difference 0, non-breakable bond, non-polar covalent bond. So N factor is 2. Here N factor is 2. OH bonds are polar bonds, no? So they can provide. So the two OH groups can give hydrogen atoms. N factor 2. So its gram equivalent weight is equal to its gram molecular weight by N factor 2. Now coming to tribasic acids. Tribasic acids, number of replaceable hydrogens, 3. Number of replaceable hydrogens 3. So N factor 3. What is the N factor? N factor is 3. N factor 3. Example, H3PO4, orthophosphoric acid. Now P double bond O, OH, all are ionizable bonds. So N factor 3. Its gram equivalent weight equal to gram molecular weight M by N factor 3. Its gram molecular weight we know very well, 98 by 3. So understood everyone? Acids we have done. Now coming to acids, we have done acids, monobasic acids, dibasic acids, tribasic acids. Now coming to bases. Gram equivalent weight is equal to gram molecular weight of base by acidity of base. Or number of replaceable hydroxides. Simply it is known as N factor. So denominator simply n factor. It is n factor. Simply it is n factor. Now, monoacidic base. Monoacidic base. What is the monoacidic base? One replaceable hydroxide is present. N factor 1. One replaceable hydroxide. No? That's why N factor is 1. N factor is 1. Example, sodium hydroxide, potassium hydroxide, rubidium hydroxide, cesium hydroxide, ammonium hydroxide, etc. Ammonium hydroxide, etc. Gram equivalent weight of sodium hydroxide is equal to its molecular weight 40 by number of replaceable hydroxides 1. 40 by 1, 40. Coming to diacidic base. Diacidic base. Two replaceable hydroxides present. Two replaceable hydroxides present. N factor is equal to 2. N factor 2. Example, calcium hydroxide. For example, calcium hydroxide. Gram equivalent weight equal to, calcium hydroxide gram molecular weight, calcium 40 plus 2 into oxygen 16, hydrogen 1 17, 2 into 17, 34, 40 plus 34, that is equal to 74. So 74 by, it can provide 2 hydroxide ions, N factor 2, that's why 37 is the right answer. What is the gram equivalent weight of calcium hydroxide? 37. Understood? $37. Now, triacidic base. How many replaceable hydroxides present? 3. 3 replaceable hydroxides present. 3 replaceable hydroxides present. N factor 3. Example, AlOH thrice. AlOH thrice. Its gram molecular weight, aluminum 27, 3 into 17, so 27 plus 51, total value 78. This is gram molecular weight of AlOH thrice. Its gram equivalent weight, how can we calculate? Gram molecular weight by how many replaceable hydroxides? 3. Now 26 is the right answer. What is the gram equivalent weight of aluminum hydroxide? 26. Now, Elements completed, acids completed, bases completed. Now very very important number, that is salts. Elements, acids, bases, now salts. How can we calculate gram equivalent weight for salts? Gram equivalent weight equal to gram formula weight of salt. For salts we can use formula weight. Gram formula weight of salt by total charge, total charge, total charge either on cation or on anion, or on anion. Simply this is called n factor. This is called n factor. I hope everyone understood. Gram equivalent weight equal to gram formula weight of salt by total charge either on cation or on anion, or simply it is known as n factor. Total charge either on cation or on anion. Example, sodium chloride. You know this is the salt. Sodium chloride is salt. How it is? How can we write Na plus Cl minus? Na plus Cl minus. Uni positive, uni negative. Now gram equivalent weight equal to sodium chloride 58.5 formula weight by charge either on cation or anion +1 -1 means you can take 1. What is the answer? 58.5. What is the answer? 58.5. Example 2. Sodium carbonate. This is also salt. How it is breaking? 2 Na plus CO3 2 minus. Now 2 positive, 2 negative. So n factor simply 2. Gram equivalent weight equal to sodium carbonate formula weight 106 by n factor 2. Total charge either on cation or anion 2. So answer 53. What is the answer? 53. Now moving to next page. Example 3. Example 3. Potash alum. Potash alum. What is the chemical formula? K2SO4 Al2SO4 thrice 24H2O. You know this is the double salt. You know it is the double salt. K2SO4 Al2SO4 thrice dot 24H2O. Potash alum. Suppose its gram molecular weight is capital M. Its gram molecular weight is capital M. Then what is its gram equivalent weight? So first we have to calculate its n factor. It is a double salt. This is one salt, this is one salt, double salt. How it is breaking? 2K plus SO4 2 minus. Aluminum sulfate, how it is breaking? 2Al3 plus 3SO4 2 minus. Now water ionization, no need to consider. 2 positive, 2 3 is 6 positive, 8 positive. 2 negative, 3 2 is 6 negative, 8 negative. So what is the n factor? 8. N factor 8. Total charge either on cation or anion, n factor 8. Now gram equivalent weight equal to gram molecular weight, or simply for salts we can use formula gram formula weight by n factor 8. Understood? Very very important. M by 8. M by 8. So like that we can calculate for salts. For salts. Now last one for redox reactions. Redox reactions. Redox reactions. We have separate lesson, redox reactions lesson is there. In that lesson you will learn very clearly. Here redox reactions means oxidation, reduction, both take place in single reaction, that is called redox reaction. Here number of electrons released or consumed, that is equal to n factor. Number of electrons released or consumed, that is simply known as n factor. Here normally I am giving for KMnO4 off cell reaction. This is best oxidizing agent. For KMnO4, you know, basic medium n factor 1, basic medium n factor 1, acidic medium n factor 5, neutral medium or faintly alkaline medium, neutral medium or faintly alkaline medium n factor 3. Simply here we can write ban 153. So now onwards you can ban one number, that is 153, basic medium n factor 1, acidic medium n factor 5, neutral medium n factor 3. This is only applicable for KMnO4. Understood? Basic medium permanganate ion converted into manganate MnO4 2-, acidic medium permanganate converted into Mn2+, and neutral medium or faintly alkaline medium MnO4- converted into manganese dioxide. By ion electron method or oxidation number method we can calculate n factors. Those oxidation number method, ion electron method you will learn in redox reactions lesson. Now one simple question. Calculate the gram equivalent weight of KMnO4 in basic medium. Calculate the gram equivalent weight of KMnO4 in basic medium. Basic medium n factor 1, ban 153, basic medium n factor 1. Now gram equivalent weight equal to KMnO4 gram molecular weight 158, n factor 1. So 158 by 1, 158. What is the answer? 158. Understood? So these are the important topics in gram equivalent weight, important points in gram equivalent weight. We have learned gram equivalent weight for elements, acids, bases, salts, redox reactions. We have learned today. So these are all very very important key points. Okay, thank you so much. Thank you so much. Thank you. We will meet in another session. Thank you.